All right, we're gonna go ahead and get started now. So first of all, I'd like to thank everyone who is joining us and welcomes today CNCF webinar, implementing canary release on Kubernetes with Spinnaker, STO, and Prometheus. So my name is Daniel. I'm working for Red Hat as a principal technical marketing major, and as well as I'm responsible CNCF ambassador. So I will be moderating today's webinar, and we'd like to welcome our presenter today, Antoine Toulme, engineering manager at Splunk, and Dave McAllister, senior technical evangelist at Splunk. There are a few couple of things, housekeeping item today. So before we get started now, so during the webinar, you are not able to talk as an attendee, but there is a Q&A box at the bottom of your screen. So please feel free to drop your question in there, and we will get to as many as we can at the end. So this is the unofficial webinar and CNCF. So, and such as is subject to CNCF code of conduct. So please do not add anything to the chat or questions that would be a violation of the code of conduct. Basically, please be respectful of all of your fellow participants and presenters. Please also note the recording and slides that will be posted later today to CNCF webinar page, www.cncf.io/webinars. So I'm gonna hand it over to Antoine and Dave to kick off today's presentation. Hey guys, take it away.
Thanks, Daniel, and thanks everyone for joining. So today, the topic of our conversation is observability of multi-party computation with OpenTelemetry. A little bit of an agenda. We'll be talking about observability and OpenTelemetry. We'll talk about multi-party computation and its challenges. We'll talk about how we can observe multi-party computation. We'll show a demo of how that's done today. We'll talk a little bit about what happens when we start having multi-parties with consortiums and a consortium architecture. I'll show a quick demo of that. And then we'll be talking about the benefits of driving with observability. So a little bit of a round of introductions for us. My name is Antoine Toulme. I'm an engineering manager at Splunk, like Daniel mentioned. I'm part of the distributed ledger technology team at Splunk. We work on all aspects of blockchain and distributed ledgers. Previously, situated at Whiteblock, working on blockchain protocols at Consensus, and before that, IoT at Acer. And I'm joined today by with Dave. Dave, go ahead.
Thanks, Antoine. Hi, I'm Dave McAllister. I'm the Senior Technical Evangelist for Splunk. I focus on observability, monitoring platforms and practices, especially around application performance monitoring here. I've worked for a number of different vendors, Scalar and Solace, but I've worked for Stanford University, for Red Hat as well, hi Daniel, as well as Adobe, among others for this. I started with open source back in Linux 0.93 timeframe, so it's very near and dear to my heart. Next slide, please. So what I'm going to start by doing is setting up some of the things around how we view observability and why we feel OpenTelemetry is the right answer for today's observability concerns. Slide, please. So observability is obviously the hot buzzword these days, but it can have lots of meanings inside of here. It actually comes from control theory. And the control theory basically is defining or designing the exposure of state variables within a manner to allow the inference of what's happening inside of the activity. You can think of this in some ways like your car. Your car will show you that it's got a problem, but inside of there's a number of different variables that are being provided that let you get more understanding about what happened at a particular moment inside of the car. But when we come to software or services, platforms or products in particular, we're actually looking at this as a quality of the software that lets us understand how the systems are behaving. And this is a big difference that's changed over the last few rounds of software design, going from the old black box monitoring style, where we're looking at Nagios and asking the box whether it's up or down, to where we're actually looking at a white box style, where we're now getting information specific to and related to the activities of choice inside of each of these pieces. Slide, please. So with that, you probably have heard these things called the 3 primary pillars of observability. And you can think of these really as classes of how we bring data in from our applications and from our infrastructure to be able to answer those unknown questions. Observability is different from the old style of monitoring because with the old style of monitoring, we knew what questions we wanted to have answered. Now we, in our complex world where we have microservices, where we have service messengers, where we are in public clouds, private clouds, hybrid clouds, we now have a huge amount of information and we may find issues that we never even thought could occur. This is not unusual to come into here. And what is observability? By bringing in all of this data into a common file format, a common way of looking at this, we can now start looking into answering questions for things that we didn't expect could ever have happened. This becomes extremely useful, particularly when we're dealing with the complexities of meeting the needs of our users. We live in an instant gratification society. A much maligned Microsoft study says that humans today have 8 seconds of attention span. And a Google study shows that if you wait for a web page to refresh for 3.7 seconds, you're likely to leave. Observability not only shows us our problems, but also can show us our performance. Slow is the new downtime. Next slide, please. But to make this happen, we need all of the data. We need to be able to bring in all of the metrics and all of the trace data. So we bring in all of the logging information here. And we need it to be open standards, open source data ingest. Your data should not be brought in through a proprietary method because you don't know what data you're going to need to add to it at any given moment for this. You need to be able to bring in all of the data all of the time. And as was mentioned previously, real time matters. The faster you can get the data in, the faster you can see what's going on in the results, the more important your data is to you. After all, think about the average cold start time for a Lambda function is between 300 and 800 milliseconds, depending on what language you're using inside of here. If you had to wait 5 minutes to see the results of this, think about how many Lambdas could have started in that single time frame to bring in this. Bringing in all the data, bringing in the data in an open format lets you then pick the right tool for the back end so that you can actually answer those questions that you're going to be faced with. Next slide, please. So OpenTelemetry started as the merger between Open Tracing and Open Census. And they were both trying to solve the same problem, but they were doing it in different ways. And it made sense to combine forces to be able to bring this together. And they started with the tracing structures, and the tracing structures for OpenTelemetry are definitely world-class, ready for production right now. Metrics is actually pretty close to being there as well, but metrics is a little bit farther behind here. A new one that we've added to this with the approval of the logging specification is logs. Now, the next thing inside of this from a dimensional viewpoint is we need to look at how we instrument, how we bring in the APIs. And each of these pieces is language specific. What you build for Go may not work for Java or Rust. And therefore, we're also at the same point in time building out across this entire model here. You need canonical implementations to be able to work with those pieces. You need a data infrastructure that meets the needs of those unique data categories, but at the same time provides a unified viewpoint here. And then you want it to interoperate with other things. This is not where we're trying to rip and replace what people have already done. Distributed tracing has been very successful and around for quite a while. Application performance monitoring has been around. Metrics, of course, has been around for this. But we want to make sure that we interoperate with all of those different pieces wherever they happen to exist. Let's go to the slide, please. And so I want to spend just a couple of slides talking about the new entry for this. And this is the logs, and the logs are in incubation. But the log data specification, the model specification is now approved. And you can go check it out on the GitHub OpenTelemetry inside of the OpenTelemetry enhancement proposals, the OTEPs, so that you can see what's going on here. It was very heavily thought about. And there were a lot of companies. The last time I checked, for instance, there's 133 companies over the last quarter that have made contributions to OpenTelemetry. It is the second most active program inside of CNCF. Only Kubernetes is higher than that. And we have a lot of log expertise. We, Splunk in particular, have a lot of log expertise. So we want to bring in here. This data specification is now finalized. It's still in discussion and we're still building it out here. But it has some things inside of here. It is designed to map between existing log formats and still be semantically meaningful. And in fact, it should be able to map from an existing data format and transfer it to the OpenTelemetry data format, and then map back to the existing data format with as identical data results as possible. This is an interesting challenge inside of here. There are lots of data formats in here. It's also designed to map between existing formats. So if you have a log format coming in a log A, you map it into OpenTelemetry logs, and then you map from OpenTelemetry logs into log B. It should be no worse than you writing code to map between log A and log B directly. And so again, retain the data information that's really important to hear this. There are 3 types of logs and events that have been identified. The first one, system logs. These are logs and events that are generated by the operating system, and of which we have no control for here. We can't change the format. We can't affect the information that's really included here. You can think syslog as an example of this. Syslog's been around and yeah, it does change, but everybody's syslog is the same. And we're not going to go and say, oh, rewrite your syslogs for all of your applications for the last 30 years. Not going to happen here. The second category is third-party applications. And third-party applications, obviously, are generated by third-party applications here. And we may have certain levels of control. We may be able to customize some of the output that's inside of here. But in general, we don't have the ability to make changes. We don't have the ability necessarily to include new information. And we don't usually have the ability to change the log aspects inside of here. And then finally, first-party applications. These are applications that we write. We develop these. We have control over how the logs and events are generated and what information we include in the logs. Having said that, let me caveat that. We have some control over the logs, because if you've got a long-running log files or long-running applications, you may not want to arbitrarily go in and change your log information, because then you won't be able to compare to historical data inside of here. So each of these pieces comes together to provide us a way of looking at logs that map to the way people use logs today. Next slide, please. Now, inside of this logging information, we also identify 2 kinds, field kinds inside of here. The first one is top name fields here. You can think of the first one, the top level fields, as things that are mandatory or frequently present in every well-known format. Think of this, for instance, timestamp. If you're writing log files, you're writing a timestamp. Now, the timestamp has specific sets of information. We know what that information is going to be. We know how it is represented, and therefore, it's a top-level field. This gives us the ability to efficiently represent those fields. We don't have to recreate or parse them on the fly. We already have that information in place inside of here. And some of the fields that you can see here. Inside of this, we are talking about OpenTelemetry. So we have traces and spans. Trace IDs and span IDs are going to be involved in every one of these things. We also are working with the W3C site. So there'll be a W3C trace span inside of here as well. And you can continue on down. The second side is the key value pairs. And here we're getting into less frequent data or data that you may want to uniquely represent inside of here. It may not be standardized. So this could easily fall into that first party application space where you're writing off data that is unique to your application or unique to your needs. And it's stored in key data pairs. This gives us the ability to do the custom data that's necessary. And that is so important in logs where we have our applications trying to tell us what's happening inside of them. Next slide, please. And so observability, particularly with this OpenTelemetry model here, starts driving this evidence-based debugging. And by debugging, I don't mean just finding the errors. I also mean finding the slowness, finding the points that make unhappy customers. You know, if you're looking at this from the model, somebody who's using your system in a request-based system cares about their specific request, how long it took, and whether it was successful. And you can think of this in literally in the set of metrics, traces, and logs as well. So you start with a high-level metric. What's going on in my system? Is my system happy? Is my system doing the things I expect it to be? Are my numbers right? I spend a lot of time working with rate error duration, red monitoring patterns for this. And it's a quick way of looking at this and making sense. The next thing you want to be able to do is drill down and detangle those. So now you want to look and say, oh, something doesn't look right. What doesn't look right? Where is it? What's the indication in here? When you're in a microservices-based environment, you may have hundreds, possibly thousands of services that are working. You may have service meshes and control planes in the background that are all working to pull these things together. You need to be able to use the tracing data to start indicating where things have happened inside of here. And then finally, with logs, you're making the right deductions based on the evidence of the specific service, of the specific application, of the specific control plane. And so these three things together give you that unique ability to start hammering out and ending those things. Because OpenTelemetry is open source under CNCF control, because it brings in all of the data formats that we need and has the flexibility to meet the unique capabilities we have, this gives us a way of making sure our data acquisition can be brought in from where we need it to be brought in and delivered to the tools that help us do the monitoring, the analysis, and the response control for each of these pieces. With that, let me turn it back over to Antoine to go through how this gets applied in real life.
Thank you, Dave. Great presentation. Loved understanding a bit more about OpenTelemetry, and we're going to show in our demo how we can shore up those concepts. So we're going to talk a little bit about multi-party computation first to kind of understand how this applies well to this complex field. So in our world, multi-party computation here is what we're going to talk about. It enables multiple actors, different companies, departments, even silos inside the same companies, to execute code without revealing their input data. The applications of these technologies are far-reaching. A simple example is to imagine creating and applying a machine learning model to determine if you will get cancer by analyzing millions of individuals' DNA without ever revealing your DNA. Multi-party computation has been a topic of extensive research for decades and has recently experienced tremendous progress. So we start, with very simple transactional approaches. Back in the day, in our transactional systems, our multi-party computations typically happen at the fringe of those side systems, such as handing off the results of a transaction between a transactional system to another. We started with a fax machine, and then legacy systems have been relying forever on EDI, for example, to pass on POs and invoices. Over time, systems have evolved to embrace RPC so they could send and acknowledge orders. Now we're seeing the use of web services, which create a tapestry between companies that expose APIs to each other. With blockchain, we can further enable trustless multi-party computation. Each party can recompute and come independently to the conclusion offered by the data by sharing the transaction across the different members of the transaction. So there's some challenges that come with that. Multi-party computations invite blind spots whenever data or computation is handed off. Distributed systems add complexity as they introduce asynchronicity and retries. It is difficult to capture the complete lifecycle of data across the actors. Put another way, those systems are not observable. So let's dive in and see how we can add observability to those multi-party computations. Now we're seeing a Cambrian explosions of new systems that maximize data integrity and execution safely, and they're no longer compromising on speed, and they're going for more and more refined use for general compute. We're seeing those systems being built by the Hyperledger Foundation, which is part of the Linux Foundation, is a sister foundation to the CNCF. a few examples of note, Hyperledger Fabric, pioneered by IBM, came out in 2015. It allows chain code, if you are familiar with blockchain, think smart contract, to create microservice execution of code between participants in a trustless manner. You can also check out Quorum, built by JP Morgan, and based on Ethereum, which allows execution of open-ended contract code that can live on the chain, allowing the use of contracts and tokens, while preserving privacy by having a private state between actors. Latest addition to the family is Hyperledger Besu, a Java-based Ethereum client for the enterprise. I'm a little biased. I'm a committer on Besu, so come and check it out. It's cool. Well, now let's see what happens, right? When we expose the systems to observability, and going back to what they said, these are all the elements of observability we are aware of, metrics, traces, and logs. We're able to understand in detail how the asynchronous nature plays a role and how it allows composability of events, meaning one transaction into the system will issue several events that we can witness and cascade into multiple business events. That's the strength of such distributed blockchain-oriented systems. The challenges of monitoring and understanding the origin of an event are huge. Building on observability and our previous slides, we can now interpret metrics, traces, and logs and marry them with ledger data to gain a complete picture of the behavior of the system. And then ledger data itself is quite complex. You have block and transactional data. You have the events being thrown by the code itself as they execute. You have data coming from the network, even just the submission of transactions through the mempool. And you have all sorts of information around the consensus data that you will want to capture in case someone is attacking or changing the current canonical chain. So now I'm going to show you a little bit of a demo to show you how those systems operate and how they manage safely to execute chain code. For this demo, we'll be showing Hyperledger Fabric. And we'll be executing some chain code, and we'll be looking at transactions coming into our Splunk instance, showcasing the transaction dashboard. We're also going to show how traces are produced by the chain code and are sent to a remote server for exploration, and how it allows much faster feedback to the development team. All this blends into great dashboards, allowing the team to participate in continuous deployment. So let's jump in. I'm going to show you here first and foremost a little bit of an overview of what is possible today to understand how Hyperledger Fabric itself runs. This is our Splunk instance. We're running this against a simple Hyperledger Fabric deployment that has something like 6 channels and 2 organizations. Well, what does that mean? Well, we have 2 different organizations that do not trust each other, and they have 6 different channels which are private in which they can exchange information. We're seeing here at a level a little bit of information about our network architectures and channels. We can also see all sorts of information coming from the metrics around health and monitoring to understand exactly how the system behaves if we're seeing a spike in CPU or hard drive. So all the traditional IT metrics that you are using today to monitor your machines are still there. They even are more exacerbated as you run on the cloud that you do not control. But for a business analyst trying to understand how the system behaves from the point of view of its use case, we like to concentrate on the transaction analytics dashboard. It allows us to understand exactly what's going on inside the chain and what data is being transferred. Last but not least, I would be remiss not to mention that we have full capacity to search any data on the chain, so we can solve all sorts of computation, and we can always go to each and every one of the metrics and dive in and understand better what's being exchanged. So back to our mantra, metrics, traces, and logs. We're now seeing metrics very well exposed here, and now we're going to understand a little bit what's going on inside the system at this time. So as I click here, I'm being transported to a transaction analytics dashboard that shows us that we are seeing a number of bids which are being executed on our chain. And this dashboard refreshes every minute. It's showing the last 60 minutes of activity. We're seeing all sorts of metrics being exposed. We can see our transaction history here, and we could dive into every one of those transactions to understand who is it for, how is it going, right? So the manufacturer here is making a transaction against the clearinghouse. We can also see all the blocks and each of the blocks transactions, so we can really understand how things are being batched in and whether we see a lot of load or not. Now, to dive in a little deeper, our developers will want a different view into this. And for that, we're going to go over to a different view called signal effects. It allows us to see a real-time view and see in the last 10 seconds a resolution of what is being exchanged on the network. We can even see the different versions of our chain code as we execute. And this has been built by a developer, friendly for their own use. They can create however how many dashboards they want using this type of metrics. So this is a view into your data that is live, allowing you to really quickly react whenever there's a new chain code deployment. You can see if it's being taken up. You can see if there's any errors being logged. We're seeing right now we have no errors being reported, which is great. And we'll be able to understand better how things go. Now, even closer to the metal, we're also able, using traces, to understand how the systems transact with each other. And I can see that we have a little bit of a map here, where we can see that there's an auction app, which is talking to a bid contract. So we're now able to correlate together different services and make sense of a blockchain in the realm of the rest of the system, and not just by itself. We can even go as low as understanding a particular trace of execution of a bid. So we can see that we have a bid, this bot action 445, which is very interesting by itself. And now we're seeing that the Node.js call that we're going to show you is calling out to the blockchain. The blockchain itself is executing the chain code twice, because as you remember, we have two organizations which are sharing this code base. So both of them do not trust each other. They're going to want to run the contract on their own environment so they can make sure this is working. In this case, they both trust the monitoring environment, so they both report back the traces, so we can understand exactly what's going on. Now, I'm going to make this a bit more concrete for the developers in the room. Here is the actual chain code that we execute, and this is very straightforward. We're creating, as part of this chain code, a number of spans, and these are the spans, the traces that Dave was mentioning. Here, we're recreating the parent span context from parameters being passed in to our chain code. Here we pass a trace ID and a span ID, and we create a Jaeger span context, which is Jaeger is an open source library for tracing. Allows us to now create our own span using the open tracing library. And we can see that this span is now executing. It's got a number of tags and key value pair values, as they mentioned, which are really interesting for us, such as the value of the bid. And you can see as we execute that span that we finish at the end, no matter what, with a finally. We even have the ability to track whether something happened in terms of errors during this execution. Now, we see that this is being passed in, a span ID and a trace ID. Well, how is that going? Well, to do that, we have a little bit of a Node.js code, which is the call that is being called from the bot to generate the bid. How do we go about that? And we just call out to the Hyperledger Fabric API, passing in arguments for chain code. And some of those arguments end up being information. So here and here are the information about the current span we find ourselves in. So we can now correlate those spans, and we can show you a neat picture of all the execution of that code over time. And we can really understand what is being triggered by what, how did these things come together, et cetera, et cetera. So I was showing you this also for a reason. As we collect the value, we now have that available to us. So just like they've mentioned, all those key value pairs become available to us. So we can now do things by understanding the value being exposed. And I can now show you the average value of a bid over time for each of the auctions, right? And this being Splunk, I can change that. I can say, I'd like to get the max, please. And we run this. And now we can see our max for each of those both auctions. So we can really instrument the data, understand everything, roll it up, even use it for all sorts of other purposes, so we can understand better our system. Now, going back to our slides. You've seen an operator working with a Hyperledger Fabric system. The operator is able to quickly understand the data exposed by the system and react to situations through observability. With the help of metrics, traces, and logs. The vision of an operator is truncated, though, to what they can see as part of their environment, right? They cannot see further than them. So I'm going to talk to you about a little bit of a daring concept in a second. We're going to talk about consortiums. And to resolve the issues of large distributed systems, consortiums are needed to work across organizations in silos. And here's a typical type of different consortiums. There can be associations of companies, or it can be associations of departments inside the same companies. In our typical experience, they form to allow greater automation and collaboration across shared critical processes that are highly valuable, right? This is not just small, no, these are the heart, the blood flow of this company depends on this type of processes. We have seen consortiums form around crude oil trading, like Congo, or banking, like Interbank by JP Morgan, or Alastria by Adara. Those consortiums are massive bets made by innovative businesses that discovered that melding their businesses with their partners had immense ramifications for the bottom line. And each of the members of the consortium have access to their own view of their data, their transactions, their past history, their private data, everything is preserved. However, consortium members need to collaborate to operate the ensemble of the system. And this is how I'm going to dive into my new demo. We're going to show you a rendering of a dashboard showcasing a blockchain deployment across multiple cloud providers, where you can see each participant has developed a complete deployment of the system that they themselves host. But it's not enough. The operators of the consortium, this congregation of blockchain members, are mandated to ensure that the consortium can operate and evolve over time. You need to be able to add, remove members, or you need to be able to amend the logic of the code running as part of the consortium. So for that purpose, I'm going to show you a little bit of a dashboard that we have been working with for a long time now, allowing us to completely understand how, at a glance, how a consortium is doing. And you can see here, we have a number of different members, and they are operating, as I mentioned, on different clouds. We're using those icons for clarity. They really help us to pinpoint the different members. And we can see that our infrastructure health check does not seem to be completely okay. So we can go as an operator and drill down, understand exactly where the data is coming from, how the insight has been captured. We can understand how that is coming together. We can see that this particular org is reporting a health metric that shows that something is failing on their end. So we should really be contacting them and understanding where they are. And those folks as well, but this being lined up in red has meaning as well. We can see live a number of transactions in the last 60 minutes. So we can really see how the whole health of the system as a whole is now available to us. And this is all possible through observability, through the ability to make sense of our data, to really compress it up and roll it up to the level of an executive dashboard that will help us make sense of very complex asynchronous multi-party computation systems. And going back to my slide, I'm now going to talk a little bit about those benefits in more detail, right? Well, we can capture what we learned so far. Observability has changed completely how we operate our businesses, and data once again rules the world. Now let's talk about this from a technical perspective. It's a breeding ground for insightful bets. It allows us to understand the second order effects of our decisions. In microservices deployments in distributed systems, in vast complex systems, it has become imperative to understand how the systems as a whole performs, from the level of the machines the system operates on to the code logic. For businesses, it significantly reduces mistakes and fraud while increasing speed and improved auditing. It's a win for everyone except the bad actors. We know the complexity of data now resides on the edge. Businesses have done a good job understanding their core operations and reporting on them. We're now facing challenges through the operation of innovative consortiums that allow businesses to automate the collaboration. So please join us and learn more. If you do one thing today, click on OpenTelemetry.io and go check us out. This is a great project. And as Dave mentioned, it's a very active project. Lots of stuff to keep up with, lots of collaboration between different companies. If you were intrigued at all by Hyperledger Fabric and what's possible right now with blockchain, check out hyperledger.org. I would be remiss if I didn't mention this last webinar was made by Steve Flanders from Splunk as well. I would definitely recommend that you watch it if you want to learn a bit more about the innards about how OpenTelemetry is eating the world. And if you're a developer like me, or I try to pass as one, check out some cool code under the OpenTelemetry collector releases. I think version 0.5 is out. I might be even, we're seeing new versions come out very quickly. And with that, thank you so much for attending, and we'll be happy to take any questions.
Awesome. Yeah, thanks Antoine and Dave for great presentation. So we are now have some time for question. If you have any question and you would like to ask, please, it's your time. Drop it in your Q&A tab at the bottom of the screen, and we will get as many as we have time for. Yeah, so there are one question just pop up in the Q&A from Daniel. So I'm going to repeat the question. So can you please provide some example of a practical application of OpenTelemetry model for actual observability solution for CNA, for example, Grafana, etc.
Oh. I'm not sure I completely understand that question, but I'm happy to try to answer a little bit. Would that be useful? You're saying you're looking to use this in conjunction with Grafana, and so the OpenTelemetry model allows you to export the data in any format you would like. The OpenTelemetry collector can send data to a Prometheus server, and from there you can easily target a Grafana server, so it would become available to you in the same way that you've just seen with our SignalFX demo.
And just to add to that, just real briefly, there are a number of companies. A lot of this work around observability started with the e-commerce sites and heavily into social media activity sites. Many of them use the other display boards, Grafana, Kibana, those various pieces, to display information coming from multiple locations. What OpenTelemetry brings into play, and we do know the ones, unfortunately I can't mention names, but we do know that there are ones that have already moved over to OpenTelemetry as their data acquisition model to do this, but are still being able to roll that data out to a Grafana type of dashboard. Generally speaking, it's an aggregate dashboard bringing in lots of data from lots of different sources, because the data isn't standardized itself. So they're bringing it in through multiple analysis tools. But yeah, look for it in e-commerce, look for it anywhere that the request touches the user. But you're seeing it a lot, particularly e-commerce and social media.
Cool. And another question from Richard is the Hyperledger Fabric integration with OpenTelemetry currently open source?
It is open source, and it's all made of standard components. So Hyperledger Fabric exposes most of its metrics over Prometheus or StatsD. For this particular example, we're using Prometheus and we're using the SignalFX agent to collect this data. We could use also the OpenTelemetry collector. It's now to a point where we can easily collect those metrics. And some of the block data, all the ledger data, is leveraged and instrumented by our team's work through the Fabric Logger, which is an open source Apache licensed tool, which is specific to Hyperledger Fabric data, gets all the data over protobuf using a standard peer connection. So yeah. All this is coming together, and you can connect that data to any source you want at this point.
Cool. Thanks, Antoine.
Sure.
So yeah, there's one question from the chat box, but yeah, I'm not sure is that, is this intended to be replacement for FrontD? He is saying the OpenTelemetry.
Good point.
So,
I don't think so.
Go ahead. Antoine, go ahead. So the short answer is no. And in fact, most of the modeling for all of these things is to bring in already existing solutions. This is not a rip and replace structure. So for instance, again, we have a customer who literally brings in FluentD into the instrumentation, combines it into the tracing data at the same point in time. There are some advantages. FluentD doesn't have quite the same data granularity that's possible through OpenTelemetry, but it's not a replace. It's not trying to do away with FluentD. We actually use FluentD internally as well. We track things with FluentD ourselves. So again, not replacement, but it is an expansion. Let's put it that way.
Cool. So yeah, I got some question by myself. I think this is working with the Hyperledger. So does it apply for all blockchain models? And how hard is it to add observability to blockchain?
Hey folks, sorry, I don't know what happened. I'm back.
Okay, repeat the questions. I don't think you heard them, Daniel.
Oh yeah, so let me try to repeat it again. This is your project is working with the Hyperledger. So I feel that, and does it apply all blockchain model with this project? And also, how hard it add to observability to blockchain?
Oh, that's a great question. Thank you for asking. So we're in early days. We're trying to first and foremost prove this is the right approach. And we have a lot of time on our hands to make this right, because we're first and foremost applying ourselves to the success of people who want to try this approach. The Hyperledger Foundation, so I'm a committer on some of the projects. I believe that we could very selectively add tracing in some of the elements. In terms of metrics, however, it's a slam dunk because all the information is already available to use for Prometheus metrics. So it's just a matter of making that more apparent and leveraging those metrics for good, right? We've had just one contact with the Hyperledger Foundation about making that maybe more part of the framework. And I think this is going to accelerate in the coming months as our maturation and our use cases get crisper. But this is very exciting for us. We're working on all those things.
Got it. Thanks for answering.
Yep. Sorry for the blip.
Yep. Okay. I think so. We think it's almost done. Okay. Thanks, Antoine and Dave, for a great presentation and a fantastic demo and Q&A or answers. All right. That's all the question we have time for today. And thanks for joining us today again. And once again, the webinar recording and slide deck will be online later today. And you just go to www.cncf.io/webinar so you can download if you missed the webinar. And we are looking forward to seeing you at the future CNCF webinar. And thanks again. Have a good rest of the day.
Thank you.
Thank you.
Bye.